Hello everyone, we are the team members from CMT ID number 1022, the participants of TIIC IDC 2015. First of all, thanks to TI for giving us this platform to share our ideas. Our project is Intelligent Wireless Electricity Load Management System.
This is the block diagram of an intelligent wireless electricity load management system. Here in the block diagram, we can see that there are the different sensors such as sensor node 1, sensor node 2, sensor node 3 and sensor node 4, which are situated at various places in the industrial area. Here the various parameters such as current, voltage and electricity are measured at the sensor nodes, and those parameters are passed to the master controller wirelessly by using an RF module. Here the master controller checks the parameters or calculates their reading and takes the action regarding to it. Here the second block diagram. Here we can see the sensor node 1 block diagram. Here there are different sensors are used such as voltage sensor, current sensor and temperature sensor. The current sensor, here the INA138 is used as a current sensor for measuring the current. The output of current sensor is in the form of voltage. The output is given to the comparator where the various voltage, here the comparator sets 1 volt reference voltage. We reference where the output of current sensor and the voltage reference are compared, and the output of comparator is given to the RF encoder. Here the direct output of a current sensor cannot be transmitted directly, so an RF encoder is used where it encodes the data of a current sensor, and RF encoder transmits the data further through RF transmitter wirelessly to the master controller. Here the second sensor we have used is a voltage sensor. Similarly as current sensor, the voltage is measured to the voltage sensor and directly given to the RF encoder. And similarly to the temperature sensor, the temperature of the various equipment are measured or sensed by using the sensor, and the temperature difference which is to be calculated, or if is there any, is given further to the RF encoder, and further it is transmitted by using the RF transmitter. The RF transmitter here is used is the RF430. Now further we can see the receiver. Receiver is the RF receiver where those data which is encoded here by using the RF transmitter is decoded by using the RF decoder. The RF decoded data is further transmitted to the system controller where the encoding takes place by using the assembly language, where the coding takes place by using the assembly language, where the data is defined for those particular sensors, and the changes or calibrated by it by the controller is further displayed on the display, that is whatever the voltage or current measured by the transmitter's current sensor is displayed on this display section.
This is the flowchart of Intelligent Wireless Electricity Load Management System. First flowchart of node. In the node flowchart, first step is initialization of ports. Initialization of ports is carried out for P0, P1, P2 and P3. Next step is measure the current from current node. After that, calculate the equivalent current and set to master node. This process is carried out again and again for sensor node design. Next to that, master node, first step is initialization of ports. Initialization of ports is carried out for P0, P1, P2 and P3. After that, read the data from receiver. Next step of this, check the received equivalent data and display it on the display. This step is carried out again and again for the master node flowchart.
This is circuit of sensor node 1. This is transmitter section, receiver section, MSP launchpad kit, and this is temperature. To perform this load management, we have used current sensor for measuring the current at different nodes. Based on the load condition, the variation in the current sensed and sent to the master node. This node to master transmission takes place with the help of RF module. We have used 443 kHz RF module. This module transmits the signal that is particular node acquiring the current at present condition. Now at the receiver side, the master which receives the signal, the output of INA138 in the form of voltage. Now the output is need to be converted into current using formula. As the output voltage further given to LM324 which is used as comparator. As we have set the reference voltage for the comparator, when the load increases above the reference voltage, the output of comparator is high. This reference voltage is transmitted to the master node. At the master node, the receiver receives the data, that is the transmitter and receiver are synchronized at the same address with the help of address lines. Now the master node generates the corresponding output that is to be displayed at the display for the indication purpose. The output is generated based on the formula. Here the master is used as a controller. Output is displayed on the LCD.
This is the INA138 circuit, where it consists of two voltage. One is variable voltage and one is constant voltage. Here we are going to keep the constant voltage to 5 volt. And this is the variable voltage, which could be varied from 0.30 volt to 60 volt. As the voltage is increased, here we can see that the data which is transmitted by the INA138 got displayed on this master board, which is the current of an 40.42 microampere. Further, when we increase the voltage from to further level, see here the current increase to 52.12 microampere. There is one formula which is used for calculating the current. As explained earlier, then as the voltage level further increased to 9 point something, here the current get increased to 68.08 microampere. Thus, by increasing the voltage respectively